Alrighty, let's go ahead and get started. So this is a demo of my final project. The final project is split into three parts. So let me zoom into this one here. Can I zoom in? Yep, there we go. So the three parts are the Android, the data center server, and the IoT Raspberry Pi. Let me first demo the Android app. It's the part that's the most lacking, and uses the Open Weather API to pull the weather data and display it on the screen. So let me join up here. I'm going to go ahead and log into my server. Hit log in, and it logs in, and you can see the weather right here. So you have Charlotte. You can change this in the code, in the options here. You have the weather in here, and the temperature, and so on and so forth. This is as far as I've gotten. There is a sidebar menu here where if you click on the home, it goes to the home. If you go on the alerts, it's supposed to populate the alerts from the database. However, it's not implemented yet. Right now, there's just menu items, which is parameterized. So once we pull in the JSON from the server, it will populate this screen right here. If you click on it, it does respond to clicks. So if this was implemented, click on this would launch a new activity that would display the various alerts. This is the same for the sensors. It's the same code, however, it's not implemented yet, but it would pull from the database the sensors, and when you click on them, it would go to a dedicated page for that specific sensor. And so same if the account isn't implemented yet, but it should be able to edit the account and so on and so forth. So far, this is all I've done for the Android app, which is obviously the most lacking. I'm going to go ahead and try to the next one. Actually, let me go through the code here. So the main activity, which is the first activity that opens up, first opens, so on create, it goes ahead and starts the activity for the login, and then gets the request to finish the login flow. If the login flow has been finished, which is on activity result, it will say its complete login is equal to true, and then it will display the home page and everything else. The login page is not implemented yet, but it just gets the username and password. This was me trying to communicate with the database. However, the app keeps crashing if you comment this. So I've been just working on that. Let's go to alerts. So the alerts fragments pretty much just has a array of different values. So the Android, iPhone, so on and so forth. If I go back to alerts, you can see the 4 different options here, and it basically just populates this array. So once we do get the app working, it will pull in the data, create an array, and use this array adapter to display the various sensors and alerts on here. And that's pretty much all I have for the Android app. Going to the next part, which is the data center server. The data center server is implemented using a various Docker containers. So if I go to my servers project and go into my Docker Compose file, and pull this over here and make this bigger. So there are 4 Docker containers in here. We have the PHP Apache server, which runs the actual PHP API. We have the SQL database here. We have the PHP MyAdmin, which basically is just a front end to the database. And we have the Python server. This Python server hosts the socket server that allows the Raspberry Pi to communicate with the API. And all of the secrets are embedded into the secrets folder. I will talk about this a little bit later. So if you needed a password or anything, you can just go into the secrets folder, go to the root password, and this has the password in it. Alright, so let me go ahead and start the Docker server. So the Docker Compose up. So I have to start the dev Docker service. So sudo systemctl dot docker service. And then I can do Docker Compose again. There we go. So yeah, it starts with 4 servers, and now the server is running. So in the data center, this is obviously Docker the 4 servers that are running. So let me go ahead with the PHP server first, the PHP Apache server. So if I switch to my browser, if I can find my browser, let me open a new browser then, and go to my localhost 8080. This will open the PHP server. So if you go ahead and log in here, test password 123. I also have the show password option here, but I have it enabled just so I can see the password. But let's say if I type in an incorrect password, it will tell me that it will return a JSON saying that this is incorrect password. This is the API call. If I do, let's do a bad username, some random password, it will tell me that there's no such user, and we have to register. If I just hit submit, it'll tell you empty value, name value is empty. I do have it, the PHP script does redirect back to the main page after 5 seconds. This just helps me test out. Let me go ahead and log in and hit submit. So once we do successfully log in, it will give you the session ID, and the user ID, and then the email. And now we have the API. So now there's 4 different opcodes that you can use through the web interface. You have the dump command, which if you hit the dump command, it just dumps all the sensors that are under your name. So I'll talk about the database later, and it shows you that all the sensors are in one single table, and the dump command only gives the sensors that are in your name. We also have a search command, which I can search in, let's say, thermostat, and hit submit. It will give me all the types of sensors that are at thermostat. So thermostat mode, let me go back and do that. Actually, let me go back here and go to my web root and do sensor, redirect. And let me go ahead and change this to 500 just so it doesn't redirect, and I can talk to you about the code a bit more. So let me go to here and do thermostat again. Hit submit. So yeah, so it will search all the types that have a thermostat in the name. So we have thermostat mode, thermostat fan, thermostat temp, and thermostat set temperature. So it basically just a search rejects of the entire database of these. And this is also limited to your user ID, so it only gives you sensors that are under your ID. So now go back. You can also search by name, by number, and by the floor. If we do a request, we can pull one single sensor. So let's do sensor ID number 4 and hit submit. It will just give me that sensor ID. So sensor ID 4 is the thermostat mode, which is on the main floor and has a state of 2, which I'm testing right now so I can show you this being changed. So if I do 5, hit submit, it gives me the upstairs thermostat. So every single sensor has a unique ID, and you can pull the data from there. You can also do an update. So let's say I do 4. So this was the thermostat mode, and I change the state to 1. It'll change the state to 1, thermostat mode. I will talk about what these states mean later on in the video. So this is the 4 opcodes you can submit through the web UI. And if you just hit log out, it will log out, and you can go back to your main page and log in. So this is just the web API. Let's go back to README. So the Python the PHP server is split into 1, 2, 3, 4, 5, 6, 7, 8 files. So database file right here. Actually, I'm gonna close this. All right. So database file basically just sets up the connection to the database. The database server name is MariaDB because that's the Docker container name. You have the username, PHP admin, which is just an admin account. That's I wanted to protect it so the root account isn't the one actually logging in. The password is from the secrets file here. It pulls the gets content. It creates an SQLi object so the PHP server can talk with the database. Includes the first run. This is basically the register user. So basically, if this is the first time running the server and the database hasn't been created, this will create the database and create the default user, and also create the default sensors, which I'll talk about once I open this file. If there's an error connecting to the database, it says failed, and connects to the actual database. Now this is included everywhere else, and basically allows any other API endpoints like the login, logout to connect to the database without having to rewrite this code. This is just an include file. The first run, PHP script, basically just sets up the database and creates the default user. So yeah, you can see all the table creation here. So create table sensors, and then there's a create table users here. And basically, all the sensors, the default sensors, are in a YAML file here. So it pulls. You can add a default sensor here, and it will automatically populate it here. So all the default sensors are here. This is from the rubric that was sent out by the professor, the TNT8. And so this basically just creates the user. The index.php is the actual HTML frontend that I just demoed earlier. There's not much going on here. It's just an input, and it's just a form that submits to the logout or login. So yeah, it's an if-else limit. If the session is set, that means if we've already logged in, then show us the, if we haven't logged in, then it shows us the username and password dialog box. If we have logged in, then it shows us all the opcodes. Sorry about that. The login PHP just does the login, so it basically checks if the username and password are actually set. Registers if we need to register to the user, because if the register is set, then it registers the user. Username extracts the username and password, and then selects the user from the user database and compiles it into an JSON request and replies back if the password is correct. If the password isn't correct, then it just replies back incorrect password. Logout is simple. Logout just unsets the username and the SQL ID, and then it destroys the session. Redirect. So I showed you redirect earlier. Basically, just redirects the user back to the the API, the web interface after 5 seconds. This won't be recalled if we're using the Android app, because the Android app just ignores this. But if we're using the web front, like the Chrome browser, it will redirect after 5 seconds. Then we get to the meat of the PHP server, which is the sensors. And basically, let me zoom out a little bit. There we go. So let's go to the bottom. So it gets the post variable and extracts the opcode. If the opcode is dump, it gets the sensors dump. If it's search, it searches the sensor. If it's a request, then it gets sensor by ID. If it's an update, it updates the database and sends a update to the device, so the IoT Raspberry Pi device, which I'll talk about in a minute. And if it's some other opcode that we don't know, it just sends it an incorrect opcode error. So the get sensors dump, if I go all the way back here, actually let me fold all of these so it's easier to read. So the get sensors dump is pretty much select everything from the sensor ID where user ID is equal to the user ID, which is stored in the session, and basically just restricts all the sensors that we pull to that user, and just converts it to JSON and returns that. If we have the search option, it does this search sensor here, which basically just creates a query, so select from sensors where user ID is equal to this, and the type is like this, so it basically just rejects search of all this and just encodes it into a JSON and returns that. Request, where are we? Sensors by ID. So it does the same thing. It selects it from the user ID and the ID. It limits it to 1, just so there's only one sensor being returned. And then the update sensor value, it just does an update sensors where state is equal to 0 and the user ID. So all SQL queries have the user ID here, just so it locks down to that specific user and we don't see any other user's sensor. And then updates device, which basically just creates a socket connection to the the Python server, which I'll show you in a minute. and just sends a JSON request saying to update the device. And then the Python server will update all the devices that are connected to it. And that's pretty much it for the Python server. Actually, there's one more, that's session. It basically just starts the session. So that's the PHP Apache server. There's more details in the README file. So if you need more, if you need a review, just go back through the README file. The MariaDB is also a Docker container. Actually, I'll have to read from here because we can't really see that. So as we stated in the first run, this is how the table looks for the sensors. We have a integer, which is the primary key, which is the ID of the sensor. We have the user ID that this sensor belongs to. We have enumeration of the sensor types. We have the name of the sensor, which is restricted to 255 characters. We have the number, which is encodes both the floor and the index number of that sensor. In hindsight, we should have split this into two different parts, which one was the floor and the other one the number. However, there's a few things we'll have to change, so I just haven't had time to change it. And then the state of it. The state is determined by this table right here. So if the type is a system, if the type is a system, which is the arm disarm, if this is what the codes are, so 0 is disarmed, 1 is stay, 2 is away. If it's the garage door, 0 is closed, 1 is open. If it's a thermostat mode, -1 is cool, 0 is off, 1 is heat, and so on and forth, if you need to read this. Thermostat temp is a variable, so it varies from some different numbers. So thermostat temp can be 65 or 77 or however you like the room to be. And then the users is this right here, which is the ID of the user, the username, email, and then the password. These two links show how long these should be. So if you click on this one, it tells you that the password should be 255 characters. And then if I go back to login, pull this over here, you can see that it does use passwords, MD5 hashes. So it is in the database in that way. So if the database is leaked, then you don't actually see the password. So it's a security measure. The recordings was not implemented yet. It was being worked on, and that would be due to time constraints. I wasn't able to finish it. The other, if I go back to here, the PHP admin is pretty simple. It's just my PHP admin. If I go to, it just works. I just go back here, localhost 8082. You can see, that's zoomed in. Sure. Is this PHP my admin, and you can see the database here, sensors and users. All right, so the Python server. Let me close everything else. So the Python server is a multi-threaded socket server. So if I go back to down to here, we can see it's a threaded TCP socket server, and it connects to this port and address. So all addresses at port 9080. And this is the connection handler, which is this class here. So let me go ahead and fold this so it's easier to read. So the handle basically, once we have a connection to the database, the handle is called. This is the connection handler, and basically just receives any communication. There's a specific protocol that we're using here, and it's in the protocol sections in the README, and it basically is a simple integer value that is the length of the payload, a new line character. I hate this. Yeah. So the new line character and then the payload. So this right here is a proper message. It's 26 characters long, and it's just the alphabet A through Z. That's the payload. Alrighty. So yeah. So it first reads the line, which is the integer and the message length. And just loops back over and over again until we've read the entire message. The message is usually a JSON, so it decodes the JSON and handles it. If the opcode is a login, it handles a login. If it's an update, it handles an update. If it's update the device, IoT device, then it updates the IoT device. and then replies back to with the status of what happened. Let me go ahead and demo this PHP, the Python server. So let me go ahead. This is my Raspberry Pi here. So let me do SSHFS. So I'm mounting my repository onto the Raspberry Pi. And so if I do an ls here, sensors, all right, and there we go. So yeah, so this is the sensors Python script, which I haven't shown yet, but I will show in a minute. And it basically just is logging in, so you can see it's logged in, and this is our session ID, and this is our token. So the Python script uses a token, while the PHP server uses a session ID. This token basically is stored in the database, and basically allows you to reconnect to the re-talk to the socket server without having to log in every single time you want to start a connection. The client is multi-threaded, which I'll talk in a minute. So now if I go ahead and push the button on my Raspberry Pi, there we go. That broke. Let me try this again. I broke something. Alrighty, let's get back to here. So let me go ahead and restart this. There was a small typo in my code. That's why it broke. Actually, there we go. Sudo kill. So when I run this, you can see that it's logged in. And so I had the button hold it down, but here's so it did send an update. Ooh, I need it. All right, let's try this again. So if I go hit sensors, so we can see that the state was changed, which because I'm holding down the button, and the database was changed. So let me go ahead and demo the Raspberry Pi. If I press the button here, the state has changed here and is updated in the database. So if I go back to phpMyAdmin, go to sensors, it's number 4 here. We can see that the state is 0 right here, the thermostat mode. Now if I go back to here and press the button again, the it recognized that the state was changed. It updated the server, and now the database should have changed. So if I go ahead and refresh this database here, you can see that the thermostat mode, which is ID number 4, is changed to 1. Let's try that again. So if I release the button, the state is 0. The Python server was updated. If I go to phpMyAdmin and hit refresh, you can see that the state was changed to 0. The fun thing is now if I go back and log into my PHP server, test password 123, session ID, and I do an update. So let me go ahead and move this to my third window here, and alrighty, so here we have we're seeing no changes here. If I go ahead and do sensor 4 and change that to state 0, actually the state is 0, so let me change it to 1. Hit submit. You'll see that the PHP server updated the Python server, which updated the IoT device here, and we've seen the state was changed here. This basically allows live changes to the IoT device without having to repull the database. So let me do that again. So let me change the state to -1. Hit submit. And then the Raspberry Pi was also updated. So it basically allows the Android app to control the IoT devices from somewhere else in the world. Let me try that again. So it works. Change that state to 0. So this is what the Android app, if it was working, would do. If I submit, it updates that, and then updates here. The state is now 0. So it's a communication from the PHP server to the database to the Raspberry Pi. All right, let's move this back to 4. So that is the server. It's a multi-threaded TCP server that just handles the connection to the database and handles updates. So if it's a login, it does the login as we shown here, logging in. If it's a update, which we showed up here, which if I connect the button, you can see again. Press the button, it recognized that the state was changed here, and that's what the update does. The device is done by the PHP server, which updates the device and basically just goes through each connection and just tells it that it needs to refresh its, that the database was changed and you need to update your state. What else? Yeah, so that's pretty much the Python server. Let's go back up. Let's go through here again. So MariaDB Python server right here. Yeah, so there's a summary in the README if you need that. So now let's go to the IoT Raspberry Pi. So let me go ahead and, so one of the issues that I had was the Raspberry Pi didn't have enough power output to handle both the screen that I had connected to it and the camera. So I'm using 2 Raspberry Pis. So if I go here, so this is my second Raspberry Pi. It's a bit more slow while we're waiting for that. So we saw the stream. This is the sensor script here. Now if I do, the stream.py is the Flash server that hosts the webcam. So now if I go back to my website here and do 192.14.8081, we can see that we have the webcam working now. It also detects movement, so on and so forth. It does not, however, record. I'm still working on that. So right now it's just a server that shows you the changes made. So those are the two parts of the Raspberry Pi. The stream, which is the script that I just showed you, the webcam. And then the sensors, which is the updating of the sensors and receiving it. Let me go ahead and do a review of the Raspberry Pi sensors. Whew. So the sensor script is also a multi-threaded client. So yeah, there's one class that's the client and the other one that's a sensor pole. So the client is basically just a socket connection to the Python server running on the server. There, I can't even do this right. Here we go. Yeah. So there's 2 different threads running. There's a socket send and a socket receive. So the socket send basically just waits on a condition variable. So because this is multi-threaded and I didn't want busy loops, it does use a conditional variable to wait for updates. So if the conditional variable is set, that means we have more data to send. So it waits on the conditional variable, and if another thread notifies it, the condition will notify. It will exit the wait, pull in new data, and then send that data over to the server. So that's pretty much the socket sending thread. It just loops back and forth, and because there's a conditional variable, it doesn't do any busy waits. There's a thread exit. It said this is a threading event. It's a thread safe flag that basically says that we want to quit the app, and you can just go. You can kill the thread. The receive is pretty much a simple while loop that just receives on the socket, and it is the same protocol as described in the protocol. It receives the length and then receives the JSON. And so this is two different threads right here. There's also a third thread that is a sensor pole here, and it basically just pulls the sensor, and if the sensor state has changed, it goes in and sends the client that we need to send an update to the database. And so that just calls the send function with the JSON or applicable JSON, and it basically notifies the sending thread. So there is about three different threads running here, 2 for the client and 1 for the sensor pole. There's more details in the sensors.py. Ooh. Yeah, sensors.py right here. Another aspect of the stream.py I would like to mention. Let's go back to the stream.py. I did consider this to be pipelined and multi-threaded. However, after doing some testing and timing, I would only see about a 17% improvement of if I did pipeline it using threads. So I didn't pushed that to a low priority, and I just never got a chance. But there is an option to multi-thread this and pipeline it to at least 2 different stages. That's pretty much my entire project so far, what I've done. Let's go over. So the protocol is pretty simple. As I spoke before, it just sends the length of the payload. And then the actual payload. In between there's a new line character, so we know the difference between the length and the payload. The payload is always a JSON encoded string. It always has either an opcode value or an error value. So these are the 5 different opcodes. 4 of these are only allowed on the PHP web front, and then 2 of them are only allowed in the socket. And then the secrets. So if I go back to secrets here, I was experimenting with SSL encryption on the socket. However, I didn't have time to get it finished working, but there are private keys and public keys for the SSL. If I had more time, I probably would have gotten it working, but that's not applicable here. The app test password is the password for the test user and the app. The PHP admin, which is the admin account on the database. This is the username and password. And then the root password, which is Tor. That's pretty much the secrets. This all the scripts and PHP server references the secrets folder. That way, if you want to change the root password, all you have to do is change it here, and it changes it throughout the entire project. That's pretty much my project. As I said, there wasn't much time to do this. I did as much as I could, and this is all I have. Any review, just go through the README, and it displays a little bit more in some detail of some different files. I have commented this as much as possible, so you can go through the code if you need to. And that's pretty much it.